Okay, this is exercise 6b, question 8, and this is find the matrices corresponding to the following linear transformations. So we're going to work from question 8f onwards. So in question 8f, I've written down what's important here. It says, first of all, that your y equals x is fixed, so it's the invariant line, and also it's a shear such that the point 1, 0 goes to 0, minus 1. Okay, remember what we've got to do for a matrix. We've got to find out, first of all, where the point 1, 0 goes to, and then you've got to find out where the point 0, 1 goes to. So we've already actually done this one. The first one sorted, it was 0, minus 1. We just need to find out where your 0, 1 goes to. So what do we know? We know that where is 1, 0, it goes back, it's a shear. I'm just going to draw on the rest of my axes here. The shear such that 1, 0, that's where it is here at this point at the minute, and it goes back to 0, minus 1, so it goes to here. So if you imagine it has gone, that's minus 1, it's gone one diagonal square to get from here to here. It's gone one diagonal square down. So we need to find out where this point goes, 0, 1. So 0, 1 is here. So if it goes, if you look at the distance where this one is from my line, it's like half a unit away from it, half a diagonal unit away from it, and half a diagonal, and this one's half a diagonal away on the other side. So this one, if this one moves one diagonal unit this way, this one's going to move one diagonal unit this way, because it shears. If it moves left on the below the shear line, then the points move left below the shear line, the points will move right above the shear line. So our 0, 1 will move, so that's going to move one across and one up. So one across will take you to 1, and another one up will take you to 2. So to get our answer for our matrix, just push this column and this column together. So my answer, I'm just going to say my answer is going to be equal to 0, minus 1, 1, 2. And that's that one done. Okay, this is 8g. This is quite a bit more difficult. It says stretch times 3 perpendicular to y is equal to minus x with y equals minus x fixed. So I've drawn on my unit square, and this is a point I want to find out where it moves to, 1, 0, and also this point, 0, 1, and also we want to go this point y is equal to minus x is fixed, and we're moving away from its scale factor 3. So if you imagine this point from here, the perpendicular distance, I'll just draw it in, sorry, this wee distance here, alright, this wee distance here is going to be tripled, so it's going to go up to here somewhere. So we've got to find what this wee length is, so we can do that using a bit of trig. Not easy, but we can do it. Okay, that's 45 degrees in here, because that's just your minus 45 degrees line, and the length of this unit square, so its length is 1. Okay, I'm going to just call this wee bit in this wee triangle opposite. So I've got sine theta is equal to opposite over hypotenuse. So in this case, that's sine 45 is equal to my opposite that I'm trying to find over 1. So the opposite then is just equal to sine 45. So the opposite is 1 over root 2. So if that's this length we now know is 1 over root 2, scale factor 3, 1 over root 3 gets multiplied by 3. So that's going to be the whole thing from here to here would be 3 over root 2. Sorry. So that's this bit here is just going to be 2 over root 2. Okay, I'm going to look at this wee right angle triangle here and see what's going on over here. So we'll just do a wee diagram of it. I've got 2 root 2. I've got 45 degrees, and I want to find, I'll call this just x and I'll call this y. I want to find these two bits. Once I get these two bits, then I can add them on to my 1, 0 to find out where 1, 0 goes to. Okay, so first of all, we'll do our cos one first. So cos of 45 equals x over 2 root 2. And then that's just going to be 2 over root 2 times cos of 45. Cos over 45 is 1 over root 2. It's just equal to x. So if you do that, multiply along the top, 2 times 1 is 2. Root 2 times 2, root 2 times root 2 is 2 as well. So 2 over 2, so your x is equal to 1. Okay, I was going to do sine of 45 to find the y, but I don't need to because it's 45 degrees. It's an isosceles triangle, so x and y will be the same. So we'll just say also y is equal to 1. Okay, so to get from my 1, 0, I have to move 1 across and I have to move 1 up. So instead of the 1 will move to 2 and the 0 will move to 1. Okay, let's see if we can use what we've just done to work out the next few bits. So I think we can really. So it'll be exactly the same. From here to here will be 1 root 2. And then you want to extend that on out. So it's going to go out another 2 root 2. So it's exactly the same transformation. It moves by same distance away. It was only 1 root 2 away, so it moves by the same amount. So you add on 1 to the top and 1 to the top here and 1 to the bottom here. So you'll get this is going to be just 1, 2. So your answer, your matrix for this one, push those two things together. The first column matrix was 2, 1. The next one was 1, 2, and that should be our answer. Okay, H is a wee bit different again. It says a shear with y equals x fixed, and it says 0, 2 goes to 4, 6. Okay, right. What we could do, which would be, we could try to find out where your 1, 0 goes to. So where does 1, 0 go to? And also find out where 0, 1 goes to, which would be perfectly acceptable. That's easy to do. But it's not going to be easy to do. We've drawn under square here. You can see your 0, 1, 0 and your 0, 1. This is where we need to find out where they go to. This is one way of doing it. And this thing is fixed. And I've just shown here that the point 0, 2, it's going to go to 4, 6. So it's going to go along here and then up to here. This would be a very horrible way of doing it if you were trying to do it this way. So we're going to go about this doing a different method. So we're going to write down what the information that they've told us. And one of the bits of information isn't very obvious really. So it says that first of all 0, 2, if I can get this pen to work, 0, 2, 0, 2, get there eventually, 0, 2 will go to 4, 6, and it also tells you that the y equals x is fixed. So just pick a point on y equals x. I've just picked the point 1, 1. So 1, 1 is fixed. So it's not going to move anywhere. So if we go with this, that means if we let our matrix be, our matrix M be, just say A, B, C, D. There's other ways of doing this. You could do this a different way. I'll talk about that in a minute. But you could say then if you did your matrix A, B, C, D to the column vector 0, 2, you would get 4, 6, and also if you did your matrix to the column vector 1, 1, you would get 1, 1. So that's a nicer way of writing it. So it has two, as just a 2 by 2 times a 2 by 2 is equal to 2 by 2. So if we just go through this, we're just going to do this using the simultaneous equations. So my 4 here is in my first row, first column. So if I look at this 4, it's first row, first column. So you're going to do my first row times my first column. So that's just going to give you A times 0 plus B times 2. So 2B equals 4. Happy days. That gives me B is equal to 2. My 1 here is in my first row, second column. So that's my first row times my second column. So that's A plus B is equal to 1. So that's A is equal to 1 minus B, and B is 2. So A is equal to minus 1. So already we've got your A and your B. Okay, my 6 here is in my second row, first column. So that's my second row times my first column. That's a D, believe it or not. So that's going to be 2D is equal to 6. Therefore, that's going to give me my D is equal to 3. And last one is my second row, second column. So that's going to be C plus D is equal to 1. So in this case, that's going to be C is equal to 1 minus 3, which is minus 2. So I've run out of space here. My M is going to be equal to, what was my A? My A was minus 1, my B is 2, my C is minus 2, and my D is 3. Okay, I'm going to show you an easy, well, what you may think is an easier way of using the inverse matrices. I'm going to do that now. I'll just rub this out and do that now. Okay, we're going to do 8H, but just slightly different way again. So we're just going to say, if we had let our matrix be equal to M, and if you do M times the same idea as we had before, I'm just going to do 0, 2, and where does 0, 2 go? It went to 4, 6, and then the point which is on your y equals x is 1, 1, and it stays as 1, 1. So what we could do, if this has just been a normal thing, we had, like, say, m times 5 is equal to 10, you would say m is equal to 10 divided by 5, but you can't do that here because we're dealing with matrices. So here, you've got to get rid of this matrix, which is multiplying the m. So we want to find the inverse of this thing. So at the side here, we'll just do that. We'll just say determinant of that thing is equal to 0 times 1 minus 1 times 2, which is just going to be minus 2. So then the inverse is going to be equal to minus a half. That's 1 over your determinant. Switch the leading diagonal elements, change the sign of the other elements. That's what you'll have. Okay, right. So what we've got, if we want to get m on its own, we're going to have to do m times that thing, your matrix, times the inverse, which was minus a half, times 1 minus 1 minus 2, 0. So you've got to put the matrix and its inverse beside each other. And notice my inverse has gone after everything on the left hand side, so my inverse has to go after everything on my right hand side. So that's just going to be still 4, 1 minus 6, 1 times minus a half. Run out of space here, I'll get rid of all that. Minus a half times my 1 minus 1 minus 2, 0. Okay, so if we do that, left hand side is dead easy. You're just going to get m times your identity. Just do that, don't even think about it, just write it in. You know you've got your matrix times your inverse, so it's just going to be the identity. Then this, pull that minus a half out in front, and this is now going to be a 2 by 2. So first row, first column, I'm doing 4 times 1, and then 1 times minus 2, so that's going to be 4 minus 2, which is just going to be 2. And then this is my next one here I'm doing is my first row, second column, so it's just going to be 4 times minus 1, minus 4. And then this is my second row, first column, so minus 6 times 1, and then 1 times minus 2, which is going to be minus 8. And the second row, second column is just going to be 6. Multiply in by the minus a half, you're going to get minus 1, you're going to get 2, you're going to get 4, and you're going to get minus 3. So hopefully that's what I got earlier on. And at my left hand side, you've got your m. Okay, just checking my answers there, and I have got one of these wrong. And the reason I've got it wrong is I've written this as a minus 6. This should have been a 6. So change that, that's a 6. And then if you do that out, that's only going to affect the second row thing, so we'll just check them. This one here, is 6 times 1, which is 6, and then 1 times minus 2, so it's going to be 6 minus 2, which is going to be just 4. And then when we go on to here, that will become minus 2. And this next one, let's just check it. So that's second row, second column, so 6 times minus 1 is minus 6. So that's just going to become plus 3, and that should be your answer. So always just check for these silly mistakes. Okay, since we made a mess of the last method in the last question, I will do it using that method again. Let's see if we can get it right. This one, it says a share with y is equal to 2x fixed, and it also tells you that 0, 4 goes to minus 2, 0. Okay, so we need to find a point which is definitely going to be on y equals 2x. So if you put your x equal to 1, y equals 2x, or y equals 2 times 1, so y equals 2, and it will stay fixed. So we're going to say let the transformation matrix be m, and we'll just say then if you have m times 0, 4, 1, 2, it's going to become minus 2, 0, 1, 2. So again, we need to find the inverse of this thing. So over at the side, we'll do this. We'll say determinant is going to equal to 0 times 2, then minus 1 times 4, which is just going to be minus 4. And your inverse is going to be equal to minus 1 over 4, so that's 1 of your determinant. Swap the elements in the leading diagonal, change the signs of the other elements. That's what you're going to have. And we'll just write that out then. So don't try and skip any steps here. Just show all your steps here. Avoid making too many mistakes. Okay, right. Now here it's important that we remember the inverse was after everything on the left hand side, so the inverse has to be after everything on the right hand side. So that's just because the order of matrix multiplication matters. So that's minus 1 over 4, that's multiplying there, remember, times 2 minus 1 minus 4, 0. Okay, all we want to do on the left hand side then that is just turn your brain off and just put that in. That is going to be your identity. A matrix times its inverse just gives you your identity. Right hand side, take the minus a quarter out front, and then this is now going to become a 2 by 2. So first element, first row, first column. First row times my first column. So minus 2 times 2 is minus 4, and 4 times minus 4 is another minus 4. So we've got minus 8. And this is my first row, second column. So first row times my second column, minus 2 times minus 1 is 2. And then you have a 0 in there, so it's just going to be 2. Now then the next one is my second row, first column, second row times first column. So 0 times 2 is 0. 2 times minus 4 is going to be minus 8. And last one is second row, second column. So 0 times minus 1 and 2 times a 0. So 0's in there, so that's going to be 0. So if you do that out, you're just going to get your m. Hopefully this is right. Minus a quarter into that thing, and I would just put it. Would I just put it into that one? Yeah, I think I would. Probably just 6 of 1, half a dozen. And minus a quarter times the minus 8 is just going to give you plus 2. Plus 2 in the bottom there, that's going to be a 0. And then this is the one I was hemming and hawing about. Would we put this in or not? So minus a quarter times the 2 is just going to give you minus a half. So you could write it as that, or you could, if you wanted, take a half outside and leave it as 4 minus 1, 4 and 0. So I don't know which one they have given in their answer, but both are right.